Hello, everybody, and welcome to Chapter 5. We are in your textbook on page 337. And I would like to do a few of these questions, and there'll be a short quiz on Savas for you. So I'm going to write the page up here. So the first one is number 1. And you want to write it on a separate piece of paper so you can show all your work or however you want to do it. It's not much room. 6/5 plus 5/6. So when we add fractions, we need a common denominator. So a good way to do that is simply multiply these two and then cross multiply that and cross multiply that. So this is a fast way of doing that. So 5 times 6 is 30. So that's a common denominator. 6 times 6 is 36. 5 times 5 is 25. So now I can add that on 1. So that's 36 plus 25. And 36 plus 25 is 61, I believe. And I'm going to make that into a mixed number. 30 goes into 60 twice with a remainder of 1, which is over the divisor. So that's a fast way to add or subtract fractions. Just double check my numbers, make sure, yep. Okay, so the next question, so we're going to do number 1. And then the next question I would like to show you is, let's do number 5. So these look very confusing. Those are called exponents and negative exponents. So the negative exponents cannot stay there. They have to be moved either to the bottom or to the top, and that will make them positive. I'm hoping you have seen that somewhere in lessons before. So I'm going to copy the question, number 2. No, it's number 5. I'm sorry. Number 5. So it's m squared, p to the power of -3, q to the power of 4, all that over m squared. These two will actually cancel out. P squared and q to the power of -2. So the ones with the negative exponents I'm making red, they have to be moved to either the top or the bottom. If they're on the bottom, they'll go to the top. If they're on the top, they'll be moved to the bottom. And then I'm going to rewrite that whole package. M squared, q to the 4th, q to the power of 2. And on the bottom, we still have m squared, p squared, and p to the power of +3. Notice the negative exponent becomes positive when I do this little maneuver. And now my m squareds cancel out. Q to the 4th and p to the 2nd. I'm going to show you how that really looks. Q times Q times Q times Q, and 2 more times Q times Q. So how many Q's do we have? 1, 2, 3, 4, 5, 6. So it's Q to the power of 6 on top. All you had to do is add the exponents. And on the bottom, we have the same scenario. We got 2 P's multiplied together times 3 more. And that means we have 5 of them. Or you could just simply add the exponents. So that's our answer for that. So then I would like to show you number 7. And it says 2/3 to the power of 4 all over 3/2 to the power of 2. So when you have an outside exponents, think of shower power. You're showering the exponent down. So the outside of the parentheses gets dealt with first. So now we have 2 to the power of 4 over 3 to the power of 4. And that's 3 squared and 2 squared, because the power goes to each one. Now I'm going to evaluate that. 2 to the power of 4 is 16. 3 to the power of 4 is, I believe, 81. And 3 squared is 9. And 2 squared is 4. So now this is, by the way, called a complex fraction. And we're really dividing two fractions. Really what's happening is it should look like this: 16 over 81 divided by 9 over 4. And when we divide fractions, we flip the second and multiply. So there's a little saying, dividing fractions, it's no lie, flip the second and multiply. And when you multiply, you can either cross cancel or you just multiply top and bottom. 16 times 4 is 64, I believe. 81 times 9. 16 times 4. 64. 81 times 9. 729. And now you can see if you can reduce this number somehow. Looking for a common factor, like 64 looks like 8 goes in it, but I doubt 729 is divisible by 8. No, I don't see any common factors right off the bat. And so I'm just going to stop here, but sometimes there's a way to make this number smaller by finding a common factor that you can divide by. So there's the steps, okay? And then also number 9. This is the long diamond method. I call it that because the diamond is that X, but there's an extra step, okay? And the reason is, so for number 9, we have a 4 in front. The leading coefficient is 4, so we have to use that extra step. So when you have a leading coefficient other than 1, that's the step. So I'm going to write them up here so you have them. The first step is multiply first times last. Number. So that's 4 times 15, which is, I believe, 60, right? So then you fill your diamond with 60 and 17. So that's the second step. Load baseball diamond. Okay, so what are the two numbers that multiply to 60 but add to 17? So my thing is I always start looking at all the factors and see if they would add to 17. 4 and 15. But they don't, that doesn't add to 17. I'm going to pause the video because sometimes that takes a little bit. Yeah, that didn't take too long. It was 5 times 12. 5 times 12 is 60, but 5 plus 12 is 17. The next step is you write two fractions. And the 4 goes on top and the numbers you found on the bottom. Then you reduce the fraction if possible. But you always want to keep it as a fraction. So if you reduce where the denominator is a 1, you have to write it over 1. So 4/5 you cannot reduce, but 4/12 is 1/3, correct? So then you attach your x to the top and you write your answer sideways. So then use fractions as answer. And then your last step, you want to do a quick check. And I always multiply first times last. So 4x times 1x is 4x squared. 5 times 3 is 15. And usually if that matches, you're okay. So there's our factored form of this. This is called the long diamond method. It's kind of like you can do it by trial and error, how you learned it maybe with other teachers. Just kind of see which ones work, or you can use this method. However you like. Okay, so that's number 9. And then we have number, I want to do number 14. The last one. So it says solve. And when we solve, we can try to factor. 9x squared plus 6x equals 0. You need 0 on one side. Okay, that has to be a must. So now try to factor this, and I see they have a common factor. Take out a 3x. So when you take out a 3x, you're really dividing by 3x. So 9x squared divided by 3x is 3x plus 6x divided by 3x is 2. Then you set each factor equal to 0 and solve. For this one, we get x is 0. And for this one, x is negative 2/3. Two solutions, two real solutions. Because it's a power of 2, you're going to have at the maximum 2 solutions. You could have 1 solution, you could have no solution. So here's how you would do that. Okay, thank you. You guys take that quiz that I put on Savas Realize. It says chapter 5, get ready quiz.